A radio telescope records a powerful burst from deep space. The signal arrives, flares for a fraction of a second, and disappears. That behavior fits the expectation. Something violent happens, something breaks. The source is gone. Then, the same region of space produces another burst. Astronomers check the data. The signal matches. The location matches. The source that should have vanished is still there. Then it happens again. And again. What looked like a single catastrophic event begins behaving like an active machine that refuses to shut down. Each new detection creates a visible problem. If the source is still alive, then many of the explanations that seemed reasonable only moments earlier stop working. A one-time explosion can only happen once. A destroyed object cannot keep sending messages, yet the bursts continue arriving. The more often the signal returns, the less reliable the original assumption becomes. The mystery is no longer the burst itself. The mystery is the survival of whatever is producing it. Something is releasing enormous amounts of energy, then doing it again, and nobody yet knows what kind of object should be capable of that. The bursts do not stop. Months pass, then years. More detections arrive from the same source. At that point, astronomers are no longer dealing with a strange event. They are dealing with a persistent object. And that immediately removes some of the most comfortable explanations. Explosions work once. Collisions work once. Catastrophic events release enormous energy by destroying themselves. Whatever is producing these bursts appears to survive. And that leaves a far more uncomfortable possibility. What kind of object can keep doing that? The question matters because the bursts are not weak. In a fraction of a second, some fast radio bursts can release as much energy as the sun emits over days. Whatever survives these eruptions is operating under conditions far beyond anything found on Earth. Understanding those conditions could reveal how matter behaves in some of the most extreme environments in the universe. The pattern finally begins to look less chaotic. As more observations arrive, astronomers stop seeing FRB 121102 as a contradiction and start treating it as a clue. The source survives. It repeats. It releases enormous bursts of energy without disappearing. That behavior begins pointing toward a particular kind of object, not an explosion that destroys itself, not a collision that happens once and ends, something far more durable. For the first time, the evidence appears to be moving toward an answer. A highly magnetized neutron star known as a magnetar appears capable of producing exactly the kind of behavior astronomers are seeing. For the first time, the bursts look compatible with an object that could remain active while producing multiple eruptions over time. The effect is immediate. For a moment, it looks as though the mystery may finally be shrinking. Instead of fighting against the repeating signals, researchers can now use those signals. Every new burst becomes another piece of information. Every return offers another chance to compare observations against the same surviving source. The strange repetition that once broke the original explanation now appears to support a new one. Confidence begins to grow. If magnetars are the answer, then finding more repeating sources should make the picture clearer. And soon, astronomers begin finding exactly that. More repeaters begin appearing. Then the catalog keeps growing. Dozens of repeating sources are identified. More fast radio bursts are discovered across distant galaxies. The sample becomes larger than astronomers once imagined possible. And that is where the story starts becoming uncomfortable again. At first, that looks like progress. If repeating bursts are the key, then a larger collection should make the pattern easier to see. More examples should strengthen the explanation. Instead, the collection starts pulling apart. One source fires repeatedly, another barely repeats at all. A new repeater appears, but its surroundings do not resemble the environments that seemed important earlier. Then another arrives with its own behavior. The expectation is simple. As the sample grows, the similarities should become clearer. The opposite happens. Every new repeater adds information, but it also adds another exception. A pattern that seemed to be tightening begins spreading outward. Characteristics that looked central in one source become less reliable when compared against another. The problem is no longer finding evidence. The problem is that every new piece of evidence seems to pull the explanation in a different direction. A repeating burst still looks like a repeating burst. The signals arriving at Earth can appear remarkably similar, yet the objects producing them no longer seem to follow the same script. That changes the meaning of the earlier prediction. More repeaters were supposed to narrow the possibilities. Instead, each discovery removes confidence that one explanation can account for everything being observed. The repetition remains real, the bursts remain real. But the assumption holding them together begins to fail. The growing catalog no longer points toward one source of answers. It begins suggesting that similar signals may be emerging from different realities altogether. And if multiple kinds of objects can create nearly the same burst, the signal itself suddenly becomes much harder to interpret. The signal still arrives the same way. A brief flash of radio energy appears from a distant galaxy, then disappears. From Earth, one burst can look remarkably similar to another, but the growing catalog changes what that similarity means. As more sources are identified, the bursts begin pointing back to different kinds of origins. The signal remains familiar, the objects producing it do not. That creates a new problem. Detection is no longer the difficult part, interpretation is. Each new burst adds another piece of evidence. Yet each new burst also weakens the assumption that a single explanation can account for the entire population. A signal that once seemed capable of revealing its source now reveals much less than expected. The repeating bursts helped expose this shift. They were never valuable because they provided a final answer. They were valuable because they showed that the original question was too narrow. The search began with the expectation that one phenomenon was creating one recognizable signal. The evidence gradually pushed in a different direction. Different cosmic objects may be capable of producing events that look strikingly similar by the time they reach Earth. That changes the meaning of every detection. A fast radio burst is no longer a fingerprint pointing toward one specific object. It begins to resemble a symptom. Different cosmic objects may be capable of producing nearly the same signal. The burst remains recognizable. The source behind it may not. That realization changes the meaning of the entire search. The search began with a simple expectation. Find enough fast radio bursts and the explanation would eventually reveal itself. Instead, the opposite happened. The catalog grew larger. The observations became better. The evidence became stronger. Yet certainty moved farther away. Fast radio bursts remain one of astronomy's greatest mysteries, not because astronomers failed to find enough of them. They remain mysterious because every new detection reveals another way the universe might be producing the same signal.